All right, so to go over this quiz review, I'm gonna go through some questions and how to approach those. So here, which angles are represented by the same point as pi over 2 on the circle? Select all that apply. So if you notice here, there's possibly more than one answer. So if I were to draw a unit circle, remember this is 0 radians. Halfway across is pi radians as I rotate uh, counterclockwise, and then all the way across becomes 2 pi. So pi over 2 is right up here. Now remember, we could rotate more than one time around. So what I'm going to do is take pi over 2, and to go full circle, I add 2 pi radians. So to combine these, I need a common denominator. So I'm going to have to make 2 pi have a denominator of 2. So to do that, I multiply it by 2 over 2. Remember, I'm not changing the value because 2 over 2 is 1. So this becomes 1 pi over 2 plus 4 pi over 2, which is 5 pi over 2. So I notice here, that is one of my answers. Now we have other ones, like what about this 9 pi over 2? Well, what if I rotated the 5 pi over 2 and went another time full circle? So I'm just going to check. What would happen if I took 5 pi over 2 plus that 2 pi? Remember, we did the work, and 2 pi is really 4 pi over 2. So we have 5 pi over 2 plus 4 pi over 2, which is 9 pi over 2. So then down here, you can also go backwards. So what if I took pi over 2 and I subtracted 2 pi? So again, that becomes pi over 2 minus 4 pi over 2. Remember here, this is 1 pi over 2. We don't show that. And then I would just subtract in the numerator. So 1 minus 4 is negative 3 pi over 2. So all three of those are answers. Now here, for what angles is the cosine of theta negative? Remember, the cosine does your x-coordinate. So on here, on my unit circle, remember this is 0, and then this is pi. And this is pi over 2. And then this down here would be 3 pi over 2. So what we would have to do for the x-coordinate to be negative, it's going to be over here. So it's anywhere between negative pi over 2 and 3 over pi over 2, but it can't be these values. So we would say it's just between pi over 2 and 3 pi over 2 exclusive, meaning you can't be there. So this 3 pi over 2, that's going to have a horizontal component that's 0. And remember, this pi does work. So I could reason about it this way. This is one way of doing it. Another way is just plugging them into your calculator. So I could put, what's the cosine of negative 5 pi over 2? So remember to put the negative button and not the minus sign. And that gave me 0. What about the cosine of negative 13 pi over 2? Oh, it's over 4, so hold on. So if I press on here, second, and then entry, I can change that. So that's a negative value. That works. And then here, I notice 5/6 pi is going to be right before here. So this is going to work as well. So I wanted to show you the multiple ways that you could figure that out. Now here, which graph represents f of theta is the sine of theta. Now you can put this in Desmos. So just go to the graphing calculator and type in f of x equals the sine of x. And before you do that though, remember the sine does the y value. And if I drew the unit circle at 0, which would be right here, the y value starts at 0. So automatically I can rule these out. These could be cosines. So I'm looking here and here. And remember, if I did the tangent function, that's where it splits like that. So this will be my answer. But oftentimes, people wonder, am I really right? And you can check that with technology. So I would just type in, what is the sine of x? So here's the sine. And then I just put in x, which is here, which would be xt, theta, or n. Then I graph it, and that graph does match. Now, looking at this picture, it says the sine of angle theta is 0.49. What's the cosine? So to solve this, we need that Pythagorean identity. So the Pythagorean identity came from the Pythagorean theorem, which is in this triangle here. If we had x and then a y, x squared plus y squared is equal to the hypotenuse squared. Well, here, the x component is the cosine. So we have the cosine squared of theta plus the sine squared of theta. And then remember, on a unit circle, the radius is 1. So that equals 1. So we know the sine is 0.49. So we have to square that. So we'd write the cosine squared of theta is equal to 0.49. And I almost wrote 0.42 there, equals 1. And then let me change that to a plus. So now I subtract that from both sides. So I would have the cosine squared of theta is equal to 1 minus 0.49. And I do need to square that, so I put the squared. So I'm going to simplify that in my calculator and go 1 minus 0.49 squared. And it's 0.7599. So the cosine squared of theta is equal to 0.7599. And then what I would do is take the square root of both sides. So this here means that the cosine of theta could equal, and it would be plus or minus. So if I take the square root of this, it gives me, it could be positive or negative 0.8717. Now, looking at the picture, the x component is negative. So I would know that this piece has to be negative. So that would be my final answer. So here, I'm just going to put cosine of theta is negative, and then just put the picture. So my last one, the point P lies on the unit circle. So find the coordinates of P using the cosine and sine. Remember, the cosine function is equal to your x coordinate. And the sine function is, or the sine of theta is equal to your y coordinate. So on my graph here, we would just put point P would be the cosine of theta and the sine of theta. And now here we need to mark a point Q on the circle where the cosine of theta and the sine of theta is 1. Now remember, or where the tangent function has a value of 1. Now the tangent of theta is equal to the sine of theta divided by the cosine of theta. So for those to be 1, we would have the sine of theta has to equal the cosine of theta. So that happens right here. Remember, this is pi over 2. That happens at pi over 4 because we would have this piece, the cosine would be positive and the same value, and the sine would be positive, and a positive divided by a positive is positive. And that also happens down here when you have the cosine being negative and the sine being negative, and a negative divided by a negative is also going to be 1 for that value. So here, this would be 5 over 4 pi. So now to explain why the cosine of negative 3 pi over 4 is equal to the cosine of 5 pi over 4, what we can do is just look at the rotation. If I did 5 pi over 4, and I moved it backwards a full circle by subtracting 2 pi, this would be 5 pi over 4 minus, finding a common denominator, I multiply by 4 over 4. So again, I'm multiplying. So this would be minus 8 pi over 4. Then you subtract in the numerators. 5 minus 8 would be negative 3 pi over 4. So you can just put here, they rotate to the same point. For our last question, what we have to do is figure out, if I did a fourth rotation, how much would it travel? Remember, all the way around is 2 pi. So if I did 1/4 of 2 pi, that's going to give me 2 over 4 pi, which is 1/2 pi, or we could write that as pi over 2. Now, to convert that into feet, what I can do is just take pi over 2, so just put in pi divided by 2, and then round it to about 1.57 feet. Same thing here, halfway around, I can go, well, what's 1/2 of 2 pi? So half of 2 pi is going to be pi. And then I know that pi would round to about 3.14. Then remember, all the way around, need to fix that right there, is 2 pi. So this would be 2 pi. What I can do here is just put in 2 pi, and then that's 6.28 feet. And then here you have 1 1/6. So 1 1/6 would be 7/6 pi. So really it would be 7/6 of a full 2 pi rotation. So you go 7/6 times 2 pi, which you would multiply in the numerators there. So that would really be 14 over 6 pi, which you could reduce into 7/3 pi, but we can keep it there for a second. So to reduce that, again, it's 7/3 pi. So 7 divided by 3 times pi is 7.33 feet. So what angle measured in radians does P travel through to make 1/4 of a complete counterclockwise rotation? So that would be right here, which again, 1/4 of a rotation is pi over 2. So now explain why the distance P travels is the same as the angle of revolution. Well, this comes from the circumference formula. So remember, circumference equal pi times d. And in a unit circle, remember the radius is 1. So 1 plus 1 gives us a diameter is 2. So my circumference equals 2 pi, which just happens to be the same as all the way around the circle. So the circumference is 2 pi. So the angle will be the same as the fraction of the circumference it goes around.